Hello everybody. Today I'm doing a thorough review, just like I did on my LG battery pack, but this is the Samsung battery pack, 36 volt battery pack from Alarm Hookup on eBay. I bought this one recently and to test and basically to compare against the LG 36 volt battery pack that he sells. This one here has the BMS, or the battery management system, attached to the side of the cell here. And hey, I tested out great. I did a thorough review on this, so if you want to watch that video, it's linked probably at the end of this video or in the video description below. This one is rated excellent. I have no problems recommending buying that one from Alarm Hookup. But this one is the Samsung battery pack, 36 volt battery pack. And this one has the BMS in the center, which I thought was a bit of a curse when I first got it. But now that I think about it, it's actually a good thing, because I've tested the one that's mounted on the side, and they come in two formats. One with a BMS mounted to the side of it, like you saw on the LG battery pack. But on this Samsung one, I have the center mounted BMS board. And so basically I get to test them both, and it works out really well, actually. Again, I'll put links to everything in the video description below, and I will be testing this in the same format as I did the other battery pack, the LG battery pack. And other than, well, I've got the specification sheets, and here's what the listing from Alarm Hookup on this battery pack here. Now, I'm confident that what he's saying in the actual description of this battery pack is accurate, but I can't really state it as as fact. Okay, I'll tell you why, and why I'm saying that. Got some flack from people because I said, hey, he's stating that they're 2200 milliamp hour cells, more like 2270 or 2310. Well, that's not the specification that Samsung puts on these. These cells, these 18650 cells that come in this battery pack, are actually electrically identical to the LG battery pack. Really, I couldn't see any difference in them. I mean, they were just, technically the same. Same capacity, same everything. Okay, so according to the specification sheet. But again, when I tested the LG cells, I did find that they were coming up higher than the 2150 milliamp hour capacity that they're rated at. Every single one of them beat that, no problem. And I suspect that this Samsung one will do the same. So we'll see when we're testing it. So I can't really fault Alarm Hookup here on his description of this battery pack. Now, again, he does say that they are rated for a 10 amp continuous, 20 amp max per cell. I can't find that 20 amp max per cell specification anywhere. Maybe he can, supply it to me, or, I can find out where it is. But if you guys can find a specification that says that the battery pack, the battery that comes in these packs, which is a ICR 18650-22P Samsung cell, if you can find those specs for me, I'd be happy to, review them and see if that's actually true. So here we are looking at the specification of this product, and basically it's a testing sheet. It gives you all the specs of the battery. And after reading both spec sheets, I got to tell you, you really should read through those spec sheets. It's amazing the amount of detail, the amount of work that they do in testing these cells to see that they're safe and that they actually are up to the specifications they state. And they are, according to their tests. I'm going to test them as well. And the torture testing, like they charge these up at 12 volts for 10 hours and they don't blow up. So I'm talking the individual cells now. I'm not talking the battery pack itself, but the individual cells are torture tested, and you can see those tests in these specification sheets if you're interested in seeing how these are actually tested. And it's quite interesting if you're into batteries. Okay, so we're going to go through this top to bottom, and I'm going to actually do the physical first, just like basically following the same format as I did on the actual LG battery pack. I just want to add a note here. I went into much greater detail on the actual bulk purchase of these and you know, the specifications of the other battery pack. And since it's, you know, identical, the LG battery pack is identical to this one, I recommend that you watch the other video on those specifics, and you know, so you can get, you know, added information that I'm not putting into this video. I want to make this one a little shorter for you guys, but regardless, the link to the other LG battery pack as opposed to the Samsung battery pack will be in the video description below for you guys, so you can check that out. And all links to everything I use will be in the video description below as well. Okay, let's do the physical here. Obviously, we have a 20 pack 36 volt 18650 battery pack here with a BMS in the center. Okay, this one came wrapped, but I don't think he advertises that they come wrapped. So you may or you may not get a wrapped one. I didn't with my original LG pack, but this Samsung one did come wrapped. The LG came like this. Well, it looked a lot nicer than that when I got it, but I've been playing with it for a while, so you know, it's been through a bit and survived quite well, by the way. So the LG battery pack I can certainly recommend. So here we have the Samsung battery pack. It is wrapped, and it comes with a standard XT60 connector, female connector on the end. So you know, that's, if you want to keep that, know that that's what it comes with. It has a small tail for connection. It is the charge and load cord, so you'll both charge with this and you will load run whatever you're going to run with it from that cord. So it will be the load as well as the charge cord. Now the LG battery pack also had the extra solder point that I pointed out in that video, in my latest video on the LG pack, and that was the, here it is, P- pad, which I soldered a cable to. And that means that basically what I found out with this BMS is that you can both charge and discharge separately. So you could be running something with one circuit while charging it with the other. That's a nice feature. I liked it. I've been, you know, definitely a plus. And I'm going to check this BMS out and see if it's got the same capability for you. So here we are. It's all wrapped. And one thing I noticed, you know, if you're expecting this to be wrapped when you get it, the wrap quality is not the greatest. I'll zoom in on this. Here we are on the end. You can see the wrap sort of covers the end plate, but doesn't cover these two terminals here, and some of the circuitry sticking out here. So the wrap is not really protecting that circuit very well on that end. And this end also shows a bit of the BMS board there as well. So yeah, the wrap is, it could be better, but if you want to wrap it better, you can always buy a separate wrap from eBay as well and wrap it yourself. But like I said, again, he doesn't advertise that they come wrapped. Okay, so let's see how much it weighs and we'll go from there. All right, here we go for the weight. I'll do the metric and imperial. And in grams, it's 937.5. So 937.5 grams, or in ounces, 33.06 ounces. Okay, so that's the weight. Let's do the measurements. Again, I'll do the measurements in metric and imperial. So the width is 73.46 millimeters, or 2.892 inches, and 2.5764. And so that's the width. Let's go for the length. We've got 131.71 millimeters, or in inches, 5.1885 inches, and in fractions 5 3/16 inches. And the thickness is 58.77 millimeters, or yeah, 58.77 millimeters, or in inches 2.3140, or 2 5/16 inch. So that's the diameters of it, or the length of the cord here. I'll give you that as well. What the heck, we're here. And this is from the actual shrink wrap tubing, so probably once I take that off, it'll be a little longer. We've got in millimeters to the end of the I'll measure it to the end of the XT from the shrink wrap. So 124 millimeters, 124.59 millimeters, and then we're going to go to inches, which is 4.905 inches, or 4 and 29/30 seconds. So that's the actual dimensions here, and we'll go from here. Next, I'm going to take the wrap off the actual unit and start undressing it and seeing what's inside. All right, let's undress this thing. I take this wrap off. I'm going to be careful not to short anything in the process of doing that. Let's start over here and start breaking this wrap off. And use the metal as little as possible. Makes me nervous, but there we go. There we go. And I can already see the purple cell here, the Samsung. Let's take them off. Seems kind of a shame to be taking this apart like this, but a little bit of white there. I don't know what that is. Some sort of residue. Maybe it's a cleaning solution of some type anyways, but it doesn't really matter. Keep going. Boom. And there we are. Zoom in on that so you can see. The ICR 18650 22P, and obviously Samsung, and more on the top here, and they all are labeled as Samsung cells all the way through. They look identical. Let me zoom out a little bit. There we go. All right. Let's take a look at the cells. Here's some says Samsung on all of them. They all look identical, really. Samsung. More here and more on top. All right, as I stated, the BMS is center mounted. So as you can see, it's on top of the 16 pack with the 4 pack on the top, and it is 2P10S. So basically it's all pairs of cells together. Nice there. I don't know what's under the tape. I'll take a look at that in a minute, but I want to show you something right off the bat that I noticed, and this is really cool for me. Looks like I got a bunch of testing points here on the actual board itself. So that looks awesome. The board looks like it's got more circuitry to it too as well than the other BMS board. So maybe I'll be able to test a little bit of balancing here. I'm not sure. But again, I thought balancing was a big issue, but the more I research it, the more I learn that, balancing is not that big a deal if all the cells are A, identical, B, equally charged when they're first put into the battery pack. They should more or less maintain a level. If they go out of balance, then more than likely the cell is starting to go south somehow. But regardless, I do have them all. It looks like I have a bunch of testing points here, B1 through B10, which is great because it's a 10S battery pack. So I'm thinking I can get my voltages off of those pads. That's going to be nice to work with. So step 1 is good. So let's look at the rest of it. Right, got a piece of tape here protecting something. It looks like the MOSFETs and the other circuitry. Pull this off of there. There we go. There we go. That's a little better. Now we can see what's going on in there. Oh, I see a model number here. We'll see what we can get on that. Bear with me. Well, obviously it's DLX 9410, and can I read under that wire? Yeah, it just says DLX 9410, and then the next thing says is ROSE, so that's the environmental stuff, and revision 1.2. So that's pretty neat. I've got individual pads here for B4, B8. What is that? Well, I can't see what B number that is. The tape is actually beating it, so that's probably B. Well, B2 if it's well, who knows what the pattern is, but regardless, B2 is over here. So Here's the circuitry so far. And let's zoom out a little bit. You can see the whole pack. There's the whole pack fully well, exposed as far as once you take the actual heat shrink off of it. I don't see a third pad that B negative, or was it P negative pad that I had on the other BMS, but I haven't fully undressed it yet, so maybe I might be able to find it. But I mean, if it isn't here, more than likely it's not going to show. I'm going to continue on with this, do a little further testing, but that's physically what we see so far on this pack. Now Samsung says that the cells should be shipped with 3.65 to 3.85 volts of energy in each one of them. So basically I'm just going to test and see what this pack is at, and we'll go from there. Should be about, well, if it's right, or what Samsung actually recommends it should be shipped at, it should be 36.5 or 38.5. Let's see where we're at. Well, 36.4 is not too bad. This is pretty well bang on. 36.5 would have been perfect, or 5 to 38.5. So, hey, 1/10 of a volt, pretty happy with, So it's shipping right, which, that fares well. I do believe that, they are shipping brand new cells, but we'll test them out, see what kind of capacity we get on them, and go from there. Okay, as I suspected, those are test points across the bottom of the BMS. I'm very happy to find that out. It makes this working with this thing way easier. I'm just going to probably solder some leads onto all those test points to actually, charge and discharge the cells and test them out like I did on the other battery pack. Great feature. Let's go through this, and I want to show you the first thing I found. Okay, so I'm going to hook my negative lead to the negative terminal on the XT60 here, and let's put it on voltage. And I want to show you something here which is really cool. Let's start by checking the voltage on the individual pairs of cells. So first one, 3.64, right? Perfect. We got 36.40 volts, so 3.64 for the first cell pack. So then we go on to the next one. This would be B2, I guess. It is 3.64. The next one, 3.64. The next one, 3.64. Next one, 3.64. 3.64. 3.64. 3.64. 3.64. 3.64. So basically, perfectly balanced battery pack. Every cell, well, every pair of cells of the S10, the 10 that are in pairs, 3.64, all of them. So that's impressive right off the bat. The battery pack comes perfectly balanced right out of the box. So I'm very happy with that. I'm wondering if that means that this is a balancing battery BMS system on this. I'm not sure, but seeing that I have all these test leads here, or test points, I can now individually charge every single one of these cells, I believe, through these ports. So we'll see what I come up with doing that, and see if I can charge and discharge through those ports, and tell you what I found. All right, here's the next thing I noticed. I got my meter on continuity here, as you can see, and if I go from this pad here that says B6, which I would say battery pack 6, to the B6 junction or a test point, I get continuity, and that's awesome. That means that I can actually charge all the cells directly from these test points and discharge them from these test points. So that's what I'm going to do. Let's try B2 here. This is B2. So B2. Again. How nice is that? I may not have to take this battery pack apart to actually test all the cells. Okay, I've soldered leads to all the test points on that board. And trust me, I know how Mickey Mouse this looks, but it's actually going to work really well for me, and I'll show you a few things with it that are going to be really cool. Number one, it's going to allow me to test every single battery, the capacity of every single pair of batteries in this pack, which was my first goal. And second of all, it's going to allow me to, I'm going to do a little experimentation. I've got this battery monitor that is an 8S battery monitor. It's pretty cool actually, and it will allow me to monitor 8 of these 10 cell packs at one time if I connect it to these leads as well. So that'll be neat to watch happening when I'm charging, so I can see how balanced it is and if it actually does change across the pack. So that's something I'm going to try and do. I'm going to experiment with that. I'm not guaranteeing that, but I am going to test individually every pair of cells in this pack, connecting through those leads. As you can see, I have them all insulated with electrical tape at the end, so there's no chance of, you know, something shorting accidentally. And of course, I'm going to be careful. If you were going to do this permanently, obviously a professional connector would be a better thing to do. But hey, this works for me. It works great at this point. What I'm going to do here, I'm going to take this whole battery pack, and before I do any individual testing, I'm going to fully charge the whole pack all the way up to what is it, 42.5, which is actually 42 volts, which should be the maximum. Then I'll try and push it over and see if the BMS stops me from doing that as well. So we'll see what happens and go from there. Here are my first initial results from the first full charge to the first full discharge of the battery pack. I want to cycle it a few times before I start testing the individual capacities of the cells, but right now I got 4.467 amp hours or 165.9 watt hours, and excellent result. Also, you'll notice that I'm at 34.28 volts. Well, the battery does recover after you stop draining it. It comes back a bit, so that's why I'm at that voltage. But the full range that I went from was 42 volts down to 27.7 volts. Now, the full range that you should, they say the maximum full range you should go is 27.5. So I didn't even go the entire full range of the battery pack, and I got a really nice result of 4.467 amp hours. So preliminary results on this Samsung cells are very promising, looking really good. So I'm going to cycle it a few more times, and then I'll start testing the individual cell capacity. All right, on the screen here we have the circuit diagram for this center mounted BMS, and it is a 10S 2P battery pack, and if you don't know what that means, it's basically outlined here in this diagram. You'll see that each one of the batteries, which is a pair of 18650s and the Samsungs in this case, and are connected together in parallel, and there's 10 pairs connected in series to make this battery pack work. Now we've got a single charge load lead going to the BMS and the battery. And so basically you charge or load from the same XT60 connector on the end of that. That's this little orange thing at the end. And, you know, it's pretty basic that way. It's more or less the way the other LG battery pack that I had that had the side mounted BMS worked. It's the same kind of connection exactly. Let's go to the next slide. But the LG battery pack with the side mounted BMS did have a third lead or pad on the BMS, which allowed you to do a power takeoff from it, which protected it from the battery pack from over discharging. I thought that was a kind of a cool feature, as you could charge and discharge the battery pack at the same time. But you know, again, nice feature, but not needed to have. It was just something they had. Now this center mounted BMS on this does not have that P pad for power takeoff. So if you're looking for that feature, you're not going to get it on that center mounted BMS. Let's go to the next slide. And it is equally connected the same way as the LG battery pack. The BMS on this Samsung battery pack is connected exactly the same way. And as you can see here, without any issue at all, it works the same way. It does provide protection for the cells and individual pairs of cells. I don't know about the balancing feature, but you know, who knows. Let's go on to the next slide here. All right, next slide, what we have is my individual results from each pair of cells that I discharged fully from fully charged at 4.20 volts. And if you can see here on the first slide, S1 is different from all the rest because you have to connect S1, your negative terminal, to the B negative pad on the actual BMS. And the B negative pad on this center mounted BMS is not actually, I don't think it is. Yeah, the B pad is actually labeled just right above. You couldn't see it right there. It says B, but that's a B negative pad on this actual BMS. And from there, I've got the positive and the negative connected to the first pack. All right, so that's how you connect the first S1 pack. And what did I get from that? I got 327 milliamp hours, which divided by 2 turns into 65 milliamp hours per cell. And I do that all the way down the line here, so you can see how I connected it and how I tested them. And 2165, that was my lowest number on this whole battery pack per cell. If we go to the next slide, we've got the highest, I believe, was 2221. Let's go back here just one more. Yeah, 2221 was my highest milliamp hour result on these individual cells. So as you can see from these slides, not a bad result. Every single actual battery pack or pair tested above this specification, which was 2150, but not quite as high as the LG battery pack in those numbers. Now, I don't know, maybe if I cycle it a few times, I'll get a better result, but understand that every time I test a pair of these cells, it's 4 hours, 36 minutes, or 4 hours and 40 minutes at the most here. And, so it takes me 40 hours to actually test the capacity on these cells each time I do this. So, I'm a little hesitant to do this test twice. Okay, I'd like to get this video done in some period of time. So that's basically it for the capacities. Again, above the specification that is on the spec sheet for these things, and I will put links to this stuff in the video description below, including the specification sheet from Samsung. So next, what I'm going to do is I'm going to test the protection circuitry on this BMS by overcharging the actual battery pack to see where it cuts off, and I'm going to over discharge it as well and see where it actually, the protection circuit actually kicks in. I've got the battery pack charged up to 41.1 volts, as you can see here on the meter, and 41.1 volts is actually the cumulative charge on all the cells before the BMS. So this voltage here is not being regulated or actually affected by the BMS, other than it was that voltage was put on those batteries by the BMS. But this is the true voltage of all the cells in the battery pack. So right now they're 41.1 volts, and then here we have my other meter, and this is showing 41.13, which is after the BMS. So this is the output from the BMS board on this battery pack, and if you round it out, you see that it's still 41.1 volts. So I've got my charger set to 42.5 and 1.1 amps, and I'm going to charge this, try and see what the over discharge protection is on this battery pack by taking it up to 42.5, and hopefully it'll cut off and show me what the point is, cutoff point is. So let's start it up and see where we're at. All right, you saw the freeze frame there, that it was 42.73 was the cutoff, the over discharge protection cutoff on the BMS. So it is working, and it is cutting it off at 42.73 volts. Now, I checked the spec sheet from Samsung on these cells, and they actually say that they're 4.2 volts each, plus or minus 0.5. So they can go up to 4.25 volts. within specification. So really, the cutoff on this BMS is what, 0.23 volts over the maximum charge point for this these cells, which is perfectly fine, because you saw when it actually cut off in that last segment that the voltage on the actual battery pack went down to 42.5 almost instantly. So it never actually overcharged the cells. So it is doing its protection. I think it's a little bit on the edge of what I would expect, but it's still doing its job. It didn't take the battery pack over 42.5, which is within specification according to the spec sheet. And I will put a link to the spec sheet in the video description below so you can see that yourself. But regardless, the voltage overcharge protection kicked in and did its job. So happy about that. Next, I'm going to check the over discharge protection and see what the cutoff is on that. So once again, the overcharge protection kicked in at 42.73. So let's do the discharge and see where the protection kicks in for that. All right, I've gotten it down actually to 27.5, and that was 3 or 4 hours ago. If you can see here, the LVP, low voltage power protection that I put on was at 27.5. So basically it went down to the level it's rated to be at bottom discharge, and then this circuit here stopped it. I wanted to do that just to do one thing for sure, and that was, show you the milliamp hours for the entire discharge from fully charged at 42 volts down to 27.5 volts. It's 4.499 amp hours. So we'll just say 4.5 amp hours for the whole thing. Divide that by 2, and you've got the actual average amp hour capacity of each cell. Over 20, but basically it'll be what, 4.5, 2.25 for each cell. So 2,250 milliamp hours per cell in this pack. So pretty awesome, really. We'll continue on from there. That, by the way, is 100 milliamp hours more per cell. 2,250 more per cell than what is specified by Samsung. So you're getting a little extra. That's excellent. So let's discharge this down past the, I'm going to turn that low voltage protection off. And basically what I'm going to do now is just discharge it till it actually disconnects again, and I'll show you that on video as well. All right, low voltage protection is off, and circuit is on. The battery voltage currently is, when I don't knock the lead off, 34.06. So let's turn on my load here. All right, we're at 1.67 amps. I'm going to let it run down and see where it cuts off. You saw where that cut off. It was 25.53. And if you also, I let the video trail after the capture there, and just so that you can see that almost instantaneously after the, even during the beep, while the beep on my inverter was still going off, that the voltage went right back to 25.89. You can see how the battery recovers quickly. Now it's at 31.34. But I left the circuit intact, so you can see that the disconnect is still here, because the voltage on the actual, off the pigtail on the battery pack is at 2.12 volts. In order to reset this, all I got to do is disconnect it and reconnect it, and you'll see that the voltage will go back up again. It is a pretty low, disconnect on the cells. Most regular 18650 cells can be taken down to 2.5 volts. Again, the specification on these cells are 2.75 volts. So yeah, a little low, but still does the job. It does protect the battery pack, and the battery pack quickly recovers to higher than the spec at 31.35 volts. So again, this is a safety feature on the BMS. You're not supposed to use the BMS to charge and discharge the battery pack. It's, you know, that's for your charger to set the limits on that. You shouldn't be charging it, you know, beyond 42 volts, and you shouldn't be discharging it below 27.5 volts according to the manufacturer specs. So if you're relying on the BMS to regulate that for you, I'd say that's a bad plan. And you know, good luck to you if you do. But you should have a proper charger for this to do this. And you know, though this is not the reason I bought this, my MPPT 7210A is an excellent charger for doing this, because it does do constant current, constant voltage charging, and you can set the limits on it without any issue at all. As well, if you wanted to get this meter here, I'll put a link to that in the video description below, because you can use that to limit or set the charging parameters any way you want with the over voltage, low voltage, and overcharge, no charge levels that you have on this thing. So awesome for that. That's my discharge test. Next, we're gonna go a little further, and I'll just recap everything I found so far on this battery pack and what I think of it. Oh yeah, let me show you the reset here. I'm gonna take the pigtail off the meter, and you see that it goes to 0. All right, as it should. A slight charge there, it's going down, and put it back together again, and you can see that the charge circuit starts all over again. So again, 31.05 here, or 12, and perfect, right? That's how you reset the over discharge protection. Just disconnect the circuit from the battery, reconnect the circuit on the battery, and boom. The BMS on this circuit is working perfectly well. Now that I fully discharged the battery pack, let's see what the balance, you know, how balanced the cells are at this point. Understand that usually the balancing on these things happens on the charge, not on the discharge. Let's see what we have here. Okay, first cell pack 3.058. Second pair is 3.041. Third pair 3.98. Fourth pair 3.127. Fifth pair 3.117. Sixth pair 3.145. 3.139 on the sixth pair, I believe, or seventh. Next pair 3.138, 3.133, and the last pair 3.127. So most of them are pretty close. The first one's the most off. I don't know why that is, but regardless, I'm going to fully charge this battery pack again, and I'll test the balance at the end of that. I've got it almost fully charged here. I didn't want to go all the way fully charged because I can manually charge these cells to balance them if they're not very balanced at this point. But I've done a full charge, and I let it go for a while, and you know, trickle charged it down. And now we're going to see what the actual voltages on these nodes on the battery are. So we'll start from there. You see, I'm the battery, the cells in the battery at 41.8, 0.9, sort of flashing in between there. And so yeah, it's full charge. So let's take the meter off the leads and go from here. So start here on the, I'm going to start on the negative, on the B negative pad, and then number 1 test point here, B1 I would say. And we're at 4.18. And we'll go to B, battery number 2 will be the second set, 4.18. 4.19, a little variance, not much though. 4.19. 4.19. Oops. All right. 4.19. 4.19. 4.19. 4.19 again. 4.19. So a 0.1 volt difference on the first couple of cells, I believe. Let's see what we got here, just to make sure. 4.18. Yeah, 4.18 on the battery pack, the second battery pack, and on the first one, 4.18. So it actually did balance it back up pretty well. I mean, 0.1 volts. I'm not going to complain about that. It definitely took it, you know, from the unbalanced state that it was when it was fully discharged to a balanced state right at this point. So whether it's a balancing or not BMS, I really can't say for sure because I can't find the specs on it. Maybe somebody here can find it and tell us what it is from the manufacturer. But the evidence here points to the fact that the battery pack is balancing the cells. So that's a good thing. It's kind of cool. I didn't have that kind of evidence on the other battery pack, on the side mounted battery pack. So, you know, I'd say that is a plus for this BMS. All right, earlier on I showed you this little charge monitor that I was playing with. I did hook it up. It's very inaccurate. I can't even recommend it for use. So, I mean, I'm sure it's fine for RC use out in the field, but for charging these battery packs, basically useless. It's too inaccurate, so don't bother with that. So let's see. We got an LG and we got a Samsung battery pack. Which one would I pick? Well, personally right now, I go for the Samsung battery pack. Number one, it's $1 cheaper and it's higher in capacity than the LG battery pack. The center mounted BMS doesn't bother me at all. It works just great. With the takeoffs, I can do whatever I want with it. With these leads that I got on there, I could manually balance it or not. From the looks of it, it looks like it's actually balancing the charge on these cells. They were 0.1 volt off, 4.18 to 4.19 volts. In comparison, I'm not even bothering to try and balance that. There's no need. They're very accurate at that point. Now the LG battery pack, I couldn't figure out whether it balances or not. It was hit or miss. So I suspect that it's not a balancing BMS on the side mounted BMS here. It does have that plus that it has that P takeoff, power takeoff pad on it that you can actually charge and discharge the battery pack simultaneously. But really, on this Samsung battery pack, if you just hooked up another one of these XT60 pigtails to the same solder points that this one is on, you could charge and discharge it at the same time as well. So it's not a big deal. So yeah, my recommendation would be to go with the Samsung, but again, it's a matter of personal preference. This BMS, if you wanted to take it off, you'd have to destroy this battery pack to take it off. This one here, just unplug it, take it off. It's just taped on, so it's a lot easier to deal with that. Now, from a battery harvesting point of view, again, the Samsung one wins because it's cheaper and you get more capacity. Now, if you have a preference for LG over Samsung, of course, buy the LG. It's just $1 more. I couldn't find any bulk purchase pricing on the Samsung battery pack. I'm sure it's very similar to the LG battery pack. So I'll put everything in the video description below, so you guys can actually make your own decisions on that. And I will put the links for both these battery packs in the video description below, so you can buy them from Alarm Hookup on eBay. One more thing I want to say about Alarm Hookup. I did reach out to him. He did get back to me, but playing phone tag, we never actually talked to each other on the phone. That's too bad, but I did do one thing. I tested to see how hard it would be to send one of these back on eBay. I just sent a note back to Alarm Hookup saying, hey, I got a bad battery BMS, I believe, and they just said, no problem, just send it back. We'll send you a new one. And I was like, oh, that's great. No questions asked. Just send them back the battery pack. They send you a new one. Not an issue. So return policy is good if you don't like either one. Definitely, communicate with them. They do communicate through the eBay message system, so no problem there. All right, that's it for my video. If you like this video and it helped you out in some way, do me a big favor. Click on the like button here in the bottom right hand corner and give me a thumbs up. That helps my channel and it helps my video, and I greatly appreciate it. Now, somewhere on the screen here, you should see a picture of me. I think it'll be around here. That is a subscription link. If you click on that, you'll get subscribed to my channel. Also, there's a second step now in the YouTube process for subscription. There's a bell icon, and if you click on that bell icon, you'll be notified every time I put a new video up, and then you can watch it at your own leisure. Once again, and as always, I want to thank you for watching and for your time.